All right, let's talk about something that probably caused a few arguments back in the day. What is a planet? It sounds like such a simple question, but the answer? Well, it's been surprisingly messy. You probably remember 2006. That's when the International Astronomical Union, the IAU, officially voted to reclassify Pluto. It got demoted to a dwarf planet, and honestly, a debate kicked off that's still kind of going on today. But here's the thing. What if this whole controversy wasn't really about Pluto at all? What if the rule they used to kick it out of the planet club is so flawed it doesn't even work right here in our own solar system? So let's get into it. We're going to look at why scientists are now pushing for a radical and frankly a much simpler new way to define what a planet actually is, based not on where it is, but on what it is. You know, for most of human history, a planet was just a planetes, that's Greek for wanderer. It was just any point of light that moved against the stars. But in 2006, the IAU said, nope, we need to get more specific, and they rolled out this new three-part definition. Okay, so here's the three-part test they came up with. Number 1, an object has to orbit the sun. Simple enough. 2, it has to be big enough that its own gravity squishes it into a nearly round shape. Also makes sense. And then there's rule number 3, the one that says it must have cleared the neighborhood around its orbit. And this, right here, is where all the trouble starts. Yeah, that whole clearing the neighborhood idea, it sounds official, but it is a total mess. It's vague. And as we discover more and more about the cosmos, it's becoming completely unworkable. I mean, the rule just fails on so many levels. For starters, we can't check the orbit of the 6,000 plus exoplanets we've already found. But forget that, the rule doesn't even work here at home. Earth shares its orbit with thousands of objects. Jupiter, the biggest planet in our system, shares its path with over 100,000 asteroids. So, by a strict reading of the rules, are they not planets either? You see the problem? It just leads to this really fundamental, kind of weird question. If you could somehow pick up Earth and move it way out to the Kuiper Belt, it wouldn't be the dominant thing in its orbit anymore. So would it just stop being a planet? Should an object's identity depend entirely on its cosmic zip code? That just feels wrong. So a new paper is proposing a major shift in thinking. Let's just stop worrying about an object's neighbors, and instead, let's classify it based on its own fundamental internal properties, the stuff that makes it what it is, no matter where it is. This new approach is so much simpler. It uses just 3 key pieces of data: mass, radius, and something called moment of inertia. Now, that last one sounds a little technical, but it's basically a fingerprint of what's going on inside the object. It tells us how its mass is spread out. Is it solid rock all the way through, or does it have a really dense core with a lighter mantle? So what scientists can do is plot these 3 properties on a chart, creating what they call a fundamental planet plane. A better way to think of it is like a cosmic lineup. You just chart the stats for every object, and they naturally sort themselves into different families. No voting needed, the physics does all the work. And check this out. When you actually plot the data, something amazing happens. See how all the small, lumpy objects like asteroids and most moons fall along that simple flat line? But then, right at a certain mass, the objects suddenly curve dramatically upwards. This is the rocky planet turnoff. And look who's on that steep curve: Mercury, Venus, and Earth. It's a clear physical dividing line that nature itself seems to have drawn. And the same exact pattern shows up again at a much bigger scale. When you plot the data for the giant planets, you see another distinct turnoff, one that separates gas giants like Jupiter and Saturn from all the smaller rocky worlds. It's like the universe is literally showing us where the different categories belong. Okay, so this brings us back to the little world that started this whole mess. Using this new data-driven map of the cosmos, where does Pluto actually fit in? Well, the data is completely unambiguous. In this plot, Pluto, that black X right there, lands squarely on the fundamental plane of moons, clustered with objects like Triton and Eris. It's physically distinct from the objects up on the rocky plane. So this isn't a demotion, it's just a clarification based on its actual physical properties. And this method even works at the super high end of the scale. The charts show a clear gap between the most massive planets and the smallest stars, the brown dwarfs. This natural dividing line is pretty much the mass you need to kickstart nuclear fusion, the engine that makes a star shine.
So this all leads to the new definition proposed by the authors. And it's really elegant. It's physics-based, and it defines a planet by what it is. Oh, and notice that it includes unbound objects. That means it also counts all those rogue planets, the ones flying solo through the galaxy.
So when you put the two definitions side by side, the difference is just stark. The old definition is all about your location. It's ambiguous and it excludes thousands of worlds. The new one is based on an object's physical nature. It's universal and it's based entirely on data you can actually measure. And this really, really matters. We've already confirmed over 6,000 exoplanets, and scientists estimate there are billions more in our galaxy alone. We desperately need a definition that works everywhere, for every planet we might find, not just the ones in our own backyard. What we're left with is this, a much more elegant and complete map of all the stuff out there. It reveals these natural families, asteroids, moons, rocky planets, gas giants, and stars, all sorted by their true physical nature, not their zip code. This new way of seeing things doesn't just settle an old debate. By giving us a better map, it gives us a powerful new tool for discovery. And it really makes you wonder, right? With a better map of the cosmos, what new kinds of worlds are we going to discover next?